Hi everyone, this is the 8th session of writing a Lisp in Python. I am going to set up the environment. I forgot to unmount it. Okay. So in the last session, I stopped before finishing the finishing the test for the interpreter. However, I tried to record another video since, and I failed the recording, so I have to roll back and remove what I did before this episode. Now that the changes have been erased, I can verify that the tests execute correctly. And this is the same result as last time, where this test file is not implemented and this file is not finished. And this file was used in order to test the function define and the define function and the creation of lambdas in order to execute Lisp functions. So if I look at the output of the test compute Lisp, which is here, I have verified that in the last session that define can define new symbols in the global environment. And so this is the evaluation of the define expression in the global environment. And now I'm going to evaluate the lambda define expression in the global environment as well. In the built-ins I had defined a lambda constructor which is not implemented yet. So this is what this will be required before using the lambda built-in. And here I get not implemented error. So in order to implement this, I need to remember what the encoding of Lisp function was, and the encoding was described here. So a Lisp function is described as a list of three values. The first is a list of arguments, which are symbols. The second one is the body, which is a list of S expressions. And the last one is the closure environment, which is used for closures, and it has to be an environment. In this case, I'm going to use the current environment, which is being used while running the built-in constructor, so this environment. The body, it can be this, but it has to be a Lisp list instead of a Python tuple. And the argument list is already done by the interpreter, because the Lisp interpreter will read the arguments as a Lisp list. I need to check the imports in this file. So I have imported function. And the constructor is Lisp function with arglist, body, environment, and the execution mode. And since the lambda constructor creates Lisp functions, the execution mode is after evaluating the parameters, and the body is a Lisp list. I think I implemented a conversion function. Yes, make list. So I'm going to use it. And I think I can return this new function as it is. I think I should also add this metadata in the lambda constructor, because lambdas are always creating from some kind of source code in some file, but I'm not going to do this now. I would rather test that the lambda constructor is working. After eval is not defined. So here this line has executed correctly, and the representation is what fails. I'm going to implement this behavior for the representation function. And the type in question is the Lisp function type, which comes from the types module. And I think I'm going to format the answer as a simple lambda constructor, so something like this. And for this I would have to format the argument list, which is contained in the function object. And since the function is a value wrapper over a const cell, I can extract the argument list and body by using cell.char and cell.cdr operators. First I'm going to unpack this to get func, which is the CDR of this value. I'm also going to take the execution mode, even if I don't need it, because I plan to add more information when representing lambdas later. Then the function oh, I forgot about this wrapper. So I thought this was the wrapper, but this is the correct wrapper. And yes, so okay, this here is already parsing the execution mode and the function value, and now I don't have to concern myself with this part of the wrapper. I just need to get the first and second element of the function value I'm getting here. Then I need to format the argument list. I'm going to do so with the represent function. And I'm going to do the same with the body. However, the body uses the body has an opening parenthesis at the beginning and the end, and I want to remove it. So I'm going to use this Python operation. And I think this is what I want to do. So I should remove the cell module here. And this should be okay. So yeah, here you can see there is an F function, an F symbol defined in the global environment, and this F function is a function because it's executed after evaluating parameters, and its definition is wrong. It's not lambda x nil, and this is what I should fix next. I think this is wrong. No, this is correct. Okay, so if I do the same here with a new definition of, if I replace this, for example, I use this, and I rerun the test. Yeah, this is correct. The code is executed correctly, and the result is the correct abstract code, and this error is what is expected. So the next step is to compute the lambda we just defined, which is going to return nil. I could try with other values first, because in the session I tried to record last time, which I didn't upload. I had problems with nil not being nil, not being equal to nil, and I couldn't find the origin of the problem, so I'm going to use 5 instead. Just to avoid spending an hour debugging a problem. So this is where I can use the compute the compute function to compute a Lisp function. And the compute function is defined here. So I should use the environment, the function object, and the function value and the arguments as a Lisp list. Yes, I think that's correct. So I'm going to copy this. I think I can get the function with a lookup. I'm not completely sure. And I'm going to execute this call in the global environment. and the arguments should contain one value. And then I just have to import what I'm using. Okay, so I had already used different import blocks here. Yes, I shouldn't use a colon. Okay, so the evaluation has finished. I would like to print the results of this computation, not the global environment, just the results. And I shouldn't have gotten a 5. Yes, this is a bug. Because this no, it's correct. Okay, I just used 5 2 times. So if I set 2 here, I am still getting a 5, which is what I expected. And I need to import the types. Int type. And this is correct, so I can remove this assert false. And I can remove this print statements. And the computation, the compute function works, which is perfect. I know there is probably a bug hidden somewhere, because if I had written nil here, I think this would have broken everything and I wouldn't have been able to fix it. That's why I had to change it to 5. But at least the trivial case of evaluating a value in a function works. now I could, for example, try to use eval instead of calling the compute function manually. This test is already written. And the goal of this test, this test should execute the same function that is defined here with eval instead of manually looking up the function symbol and creating the argument list. So what I want to do is go from this to this. And I can reuse the function because this test uses a global environment from the built-ins and modify the global environment instead of creating a new environment. And if this works, this should simplify all the future tests by reducing the amount of code I need to implement this test. So I'm just using the evaluate function and I need to parse the code. I'm going to copy this code here. I'm not used to these functions I created in the parser. I forgot how to use them. Usually when I try to write a programming language, I use a simple parse function which goes from this to the abstract syntax tree. Maybe I forgot I wrote something for this. Apparently not. Apparently no. Yeah, because this is a Lisp, so expressions must be read one by one, but the tokenizer works in a single pass. That's why I have to tokenize before processing the tokens. And the tokenizer is not written on its is not going to use a string as an input because I implemented this as an additional layer for debugging purposes. So I need to copy this code every time I want to parse a file. this is just a coherency check. If the code is not represented this way, then something is wrong with the parser. So you would like to detect this before doing anything with the code. Then I can probably evaluate the expression. And I'm just going to print the result before writing assertions. And I'm writing this line so that PyTest shows me the output of this function. Okay, perfect. So I get 5, which is what I expected. And I can write it as an automated test by hard-coding the output type and value. So that I don't need to print the result in every time. And this is correct. I can run eval on this line and get the correct output. So the next steps would be probably adding more compute tests, like computing macros, special functions, and expanding macros before evaluating code. And I can also add more compute function tests. I'm not sure how to name this function, but the idea is that I would have a file here which would contain many definitions, like this for example, which instead of returning a constant would return a parameter, this which would return a unique value like nil, and since I'm going to evaluate every expression one by one, I don't need to name them differently. So I could have, for example, more parameters and verify that the parameter I'm returning is the correct one. Or I could have a closure which creates a dynamic function that returns from its environment. And I'm sure most of them won't work from the start, but this must all validate before I can start making some serious lambda calculus in Lisp. I think we can stop now. There are many other built-ins that I have to implement. I have finished define and lambda. I already had quote and inspect. Quasi quote is very important for because I don't want to bootstrap it from quotes. Quasi quote is what in Common Lisp is what allows to do something like this, where I can return this quoted expression, but x is not quoted and is substituted by its value. And it's very common to abuse quasi-quote in Common Lisp because that's the best construct for generating parametered code with metaprogramming. And Scheme doesn't use this function because they have other constructs like define syntax or syntax rules, which do almost the same thing but without quasi-quote. But I'm not a Scheme expert, so I'm going to use quasi-quote. I think I'm also going to need this function later, and I don't want to forget it. This is a function that creates, that generates a symbol, which is never used by anything else. So, in the symbol type, here a symbol is defined as a Python string, but another way to define symbol would be to have a second attribute that specifies if the symbol is unique, and if the symbol is unique, then its value is an ID instead of a string, because this is used in order to dynamically generate variables in Common Lisp macros for metaprogramming. So it's also very useful to have a function to generate symbols arbitrarily. Yes, I think I will try to make shorter sessions from now on, because having 1 hour long videos is probably too long. And I'm going to stop here after committing everything. Okay, so I can unmount the remote directory, and that's it.